Think the speed of light is just a number, 299,792,458 meters per second. Fast, sure, the fastest thing in the universe. But calling it fast barely scratches the surface. What if I told you that this number isn't just a speed? That it's a key to understanding the very architecture of reality? That by truly grasping what this number means, you can see space, time, and the universe itself in a completely new way? Most people never stop to ask why light has a speed limit. They hear, Einstein said so, and accept it without a second thought. But that's not an explanation. That's just repeating a name, not uncovering the truth. Here's the real story. The speed of light is not merely a measure of how fast photons travel. It's a fundamental limit built into the universe itself. It's a property of space-time, woven into the fabric of reality in such a way that trying to exceed it is literally meaningless. It isn't arbitrary. It isn't a rule someone decided on. It's the structure of cause and effect, the way the universe guarantees that events follow a consistent order. To understand this, think about motion in everyday life. If you throw a ball while standing on a moving train, the ball's speed adds to the speed of the train. That's intuitive. That's how motion works for ordinary objects. But light does not follow these rules. Shine a flashlight while standing still. You measure 299,792,458 meters per second. Now, get on a train moving at half the speed of light and shine it forward. The light still travels exactly 299,792,458 meters per second. Move at 99.9999% of light speed. Still exactly the same. Light refuses to cooperate with intuition. Its speed is constant for every observer, everywhere, no matter how fast they are moving. Why? Because space-time itself bends, stretches, and compresses to keep light's speed constant. Time slows down, distances contract, and motion behaves in ways that defy our everyday experience. These aren't illusions. They are measurable, undeniable effects confirmed by experiments, from GPS satellites that must correct for time dilation, to particles in accelerators that require exponentially more energy as they approach light speed. The universe literally reshapes space and time so that the speed of light remains the ultimate constant. And here's the astonishing consequence. Nothing with mass can ever reach the speed of light. The closer you get, the more resistant you become to acceleration. Your inertia grows. The energy required to push you faster approaches infinity. In other words, the cosmic speed limit isn't about engines or fuel. It's about the universe itself saying, no, you cannot go faster. Only massless particles like photons can travel at light speed, and they must. Anything with mass can approach it, but never reach it. So the speed of light isn't a number we plug into formulas. It's the defining factor that shapes reality. It determines how time flows, how distances are measured, how cause and effect propagate through the cosmos. It's the invisible scaffold that holds the universe together. Understanding it doesn't just explain why light travels fast. It explains why time exists, why motion behaves the way it does, and why the universe is coherent and predictable at all. Let's start with something everyone understands. Objects fall. Drop a ball, a rock, or anything at all. It falls to the ground. Galileo measured this centuries ago and discovered something remarkable. In the first second, an object dropped near the Earth's surface falls about 16 feet. Simple, right? But now, let's expand our view from the small to the cosmic. Think about the moon. The moon doesn't just fall straight down toward Earth like a dropped ball. Instead, it orbits our planet, gracefully tracing a curved path through space. But here's the fascinating part. In a sense, the moon is falling. It's constantly being pulled toward the Earth by gravity. But because it also has a sideways velocity, it keeps missing. It's perpetually falling while moving sideways fast enough to stay in orbit. This, in essence, is what an orbit really is, a continuous free fall, perfectly balanced by motion across space. What seems like a simple circular path is actually a constant battle between gravity pulling inward and motion carrying outward. Newton's brilliance was in understanding how gravity works over distance. He realized that the force pulling the moon toward Earth is weaker the farther away the object is. The moon is about 240,000 miles from the Earth's center, roughly 60 times farther than we are standing on the surface. Applying what he called the inverse square law, Newton predicted exactly how much the moon should fall toward Earth each second. The result was extraordinary. The moon's motion matched the prediction perfectly. Two completely independent observations, how objects fall on Earth and the moon's orbital motion, suddenly connected under one elegant, universal law, gravity. But Newton didn't stop there. With this insight, he could explain much more than just orbits. The same law accounted for the tides, revealing why there are two high tides each day instead of just one. It explained why planets are roughly spherical and why they aren't perfect spheres, with bulges at the equator caused by rotation. Even the motion of distant planets and moons became predictable, their paths explained with astonishing accuracy. What Newton achieved was more than just a theory, it was a revelation. The universe is interconnected. Phenomena that seem completely unrelated on the surface, falling apples and the moon orbiting hundreds of thousands of miles away, are governed by the same underlying principles. Gravity, in Newton's hands, was no longer a mystery force. It became a precise, measurable law, a key to understanding the mechanics of the cosmos. Science, by this point, was entering what could only be called an avalanche of discoveries, a cascading chain reaction of insights that has continued for over 400 years. Observations, experiments, and bold thinking built on one another, unlocking deeper and deeper layers of understanding about the universe. And then, in this unfolding story, light entered the stage, and everything changed. For centuries, people assumed that light traveled incredibly fast, but the question remained, how fast exactly? Once the speed of light was measured, a profound and shocking truth emerged. Light always travels at exactly the same speed, 299,792,458 meters per second, no matter how fast you are moving. This is nothing like anything we experience in daily life. Throw a ball from a moving train, and its speed adds to the train's speed. But light refuses to behave this way. Shine a flashlight while standing still, 299,792,458 meters per second. Ride a train moving at half the speed of light and shine it forward. Still 299,792,458 meters per second. 90% of light speed? Still the same. Even at 99.9999% of light speed, light doesn't speed up. It stubbornly holds its value, constant for all observers. This is where Einstein's genius comes in. He realized that the reason light behaves this way is that space and time themselves are not fixed. They bend, stretch, and contract to preserve the speed of light. If you move faster through space, time itself slows down for you. Distances along the direction of motion shrink. These aren't optical illusions or errors in measurement. They are real, physical phenomena that have been confirmed repeatedly through experiments. The universe, in effect, rearranges itself, adjusting time and space to ensure that light always travels at the same speed for everyone, everywhere. And here's the mind-blowing consequence. Nothing that has mass can ever reach the speed of light. The closer you get to this cosmic limit, the more resistant your mass becomes to acceleration. The universe imposes a strict rule. The energy required to push an object closer to light speed grows without bound. To actually reach light speed, you would need an infinite amount of energy, literally impossible. Mass and energy, motion and inertia, all conspire to make this speed an unbreakable barrier. Only massless particles, like photons, can travel at light speed, and they must, because they have no mass to slow them down. In other words, the speed of light is not just a number. It is a fundamental property of reality. It is the ultimate speed limit, baked into the very fabric of space-time, dictating the rules of motion, causality, and the flow of time itself. Understanding this isn't just an intellectual exercise. It's a key to unlocking the deepest truths about the universe, revealing a cosmos far stranger and more beautiful than our everyday intuition could ever imagine. Light can travel at this ultimate speed precisely because it has no mass. But here's a subtle yet profound truth. The cosmic speed limit doesn't exist because light is special. Light is merely a messenger, traveling at the maximum pace that the universe allows. The real reason for this limit lies in the structure of spacetime itself. Space and time are not separate, rigid entities. They are woven together into a single, dynamic fabric, and that fabric has a built-in maximum rate at which cause and effect can propagate. That rate is the speed of light. What does this mean in practical terms? Imagine moving faster and faster through space. To do so, you can't just push harder or use more energy. The universe imposes a fundamental trade-off. As your motion through space increases, your motion through time must decrease. In other words, to speed up spatially, you borrow from time. The closer you approach the speed of light, the more time slows down for you relative to everything else. At the speed of light itself, time comes to a complete stop. From a photon's perspective, there is no passage of time. It is emitted and absorbed in a single, timeless instant. This is why nothing with mass can ever exceed the speed of light. It's not a limitation of engines, fuel, or technology. It's not a rule humans invented. The universe itself forbids it. To try to go faster than light would require negative time, a concept that makes no sense and breaks the very logic of cause and effect. The cosmic speed limit is a law written into the fabric of reality, not a suggestion. And these aren't just abstract ideas. They have been tested and observed countless times. GPS satellites orbiting Earth must account for time dilation caused by both their speed and the weaker gravity at their altitude. Without these corrections, GPS readings would be off by miles every single day. Particles called muons, created high in the atmosphere by cosmic rays, live far longer than expected because they're traveling close to the speed of light. Time slows down for them, allowing them to reach the ground before decaying, just as relativity predicts. In short, the speed of light is more than a number. It is a fundamental constant of the universe, a built-in limit on how fast information, energy, and causality can move. Everything we observe about motion, time, and space is shaped by it. And the fact that we can understand, measure, and even predict these effects is a testament to the profound and beautiful order underlying reality itself. Particle accelerators provide some of the clearest evidence of this cosmic law in action. The closer scientists push particles to the speed of light, the more resistant they become to acceleration. No matter how powerful the machinery, no matter how much energy is poured in, the particles approach the speed of light asymptotically. They get infinitely harder to accelerate. Every single experiment confirms the theory perfectly over and over again. This isn't hypothetical, it's reality, measurable and undeniable. But the speed of light is far more than a number or a curious experimental result. It is a fundamental key to understanding the universe itself. It defines the rate at which events unfold, the speed at which information travels, and the maximum pace at which cause and effect can propagate. It is the ultimate speed limit, not imposed arbitrarily, but encoded in the very structure of space and time. Light doesn't just move fast, it sets the rhythm of reality. The story of how humanity discovered this limit is itself remarkable. It begins with Newton, observing the moon and realizing that the same law of gravity that makes an apple fall also governs the motions of celestial bodies. Centuries later, astronomers studying the moons of Jupiter measured the speed of light, revealing that it is not instantaneous but finite. Then Einstein, with a single stroke of genius, revealed the underlying connection between light, space, and time, creating the framework of relativity. Since then, thousands of experiments, from particle accelerators to GPS satellites, have confirmed these predictions with stunning precision. This is how scientific discovery works. One insight builds on the next, each observation unlocking new understanding. What started with falling apples and orbiting moons has grown into a profound understanding of the universe itself. The speed of light is more than just a measurement. It is a thread connecting centuries of exploration, a constant that reveals the astonishing, beautiful, and sometimes counterintuitive structure of reality. The universe is not simple. It does not exist for our comfort or convenience. Its rules are complex, its patterns often counterintuitive, and its behavior can seem utterly alien. And yet, it is breathtakingly beautiful, elegant, precise, astonishing in its order and consistency. Amid all this complexity, there is one constant that binds it together: a thread running through the fabric of reality itself. That thread is the speed of light. It shapes how space bends, how time flows, how cause and effect unfold. It is the rhythm to which the universe dances, the invisible measure that makes the cosmos intelligible. Without it, nothing would hold together. With it, the universe reveals a subtle, astonishing harmony.